have to concentrate on the slides and not on my face here. Hope that is okay too. So my name is Simon Fleischer. As Michael already said, I'm a software engineer at Console. And yeah, we are starting that webinar series with the subject Cloud Transition Strategies. And maybe some of you do not know Console that well. I will say a few words about Console first. Don't worry, only one slide. So what are we doing here at Console? First of all, we are doing IT consulting, IT solutions. For example, we have one own product. It's called Console CM. And we are doing a lot of software engineering, which is my part, and IT operations. So now let's start directly with today's agenda. The series of that webinar, the webinar series is called Crisis-Proof Software. So we will first have a look at what does that mean at all. So where do crises come from? From what can they be triggered? And afterwards, we will have a look at the cloud itself, how the cloud can be of any help with crisis-proof software. And then we will have a look at the migration strategies, how you can make use of the cloud, how you can deploy your software in the cloud, how you can manage to migrate your software. And finally, I have a few tips and tricks for you. So now, what is crisis-proof software? Of course, it should handle your requests like you want to correctly. So of course, no data should be lost and it shouldn't slow down. It's obvious, and in an ideal world, your application shouldn't care about any crisis. It keeps your business up and running. So we want to reach that ideal world, and let's see how the cloud maybe can help you later. And what first we will have a look at what a crisis can be triggered, how a crisis can be triggered. So you can think of hardware defects, network outages, but of course lack of human resources. So if nobody is there who runs your software, you might have a problem. Of course, you might be a victim of hacker attacks, of security incidents, and especially in these times, viruses can be a danger for your software, not only for the software, but of course, in these times, for human resources too. So you have to think about this, about viruses as well. So now let's assume you have a very big cluster in your computing center or in your basement wherever you host your application, and then no customer wants to use that. Sounds not that good, right? So that can lead to a crisis, as well as success the other way around. So your system is too weak to handle all the requests. So what can the cloud do? First of all, I don't think that I have to describe what the cloud itself is, but anyway, I like that quote very much. It's from Mark Benioff, the founder and CEO of Salesforce. If someone asks me what cloud computing is, I try not to get bogged down with definitions. I tell them, simply put, cloud computing is a better way to run your business. So let's see if he's right. Cloud can help you in many ways. One few examples is DevOps. The first example here is DevOps. You probably heard of that phrase, you build it, you run it, and that's very easy to do with the cloud. You can, of course, do that with your classic IT in your basement or whatever, but the cloud is really a good help here to live that DevOps principle. Then it can save you money, of course. It can save money if it's done right. If you do it wrong, it can cost more money than before. But in general, there is a good possibility and a good chance that you save money with migrating to the cloud. Then scalability. Let's take that example that all your customers want your product, and there's a run to your services, and your server, your cluster, whatever you use, is too weak. So you won't probably have that problem in the cloud because you can scale massively. And you gain extremely flexibility with the serverless approaches like Lambda and Aurora. So you don't have to care about any scaling, and it's done more or less automatically with these services. They grow and they shrink like you need. And in most cases, you don't even notice that some scalability or scale, that the scale was changed. Then you should think about what is your core business at all. So is your core business about the redundancy of hardware or the redundancy of human resources? Pardon that phrase, but I think it's you know what it's meant by that. And do you really want to base your business on securing operating system? Is that your core business? So that might be, of course, but in most cases the answer is no. So you can outsource these tasks, and the cloud can be a very good help here. Furthermore, the cloud helps you a lot with disaster recovery. Again, in most cases, you won't even notice that disaster recovery happened. You probably didn't hear in the past about a service which crashed because of a failing, let's say, hard drive in AWS or in any other cloud. So they are doing that in that transparent that you don't even notice that something happened. And one of the most important issues here is that you can concentrate on what matters most, which is, of course, your business. So now let's have a look how we can migrate to the cloud. We have here different migration strategies we will talk about, and they are sorted by level of abstraction. I called it that way. The first one will be rehosting using infrastructure as service, so, also known as lift and shift. It has a very low level of abstraction. There is nearly no abstraction. So let's have a look at that in more detail. One example would be AWS EC2. So for those who don't know what that is, you rent instances on operating system level. So you get the root access to that EC2 instance, and you can do whatever you want on that instance, which means that you have to take care about all the software which is running on that instance. So that is a very good start if you don't know if your application is ready for the cloud. With an EC2 instance, it most certainly will be. So it has a very short path to your first success. It has very low implementation costs because in most cases you can simply deploy your application on that EC2 instance, and you don't have to do anything with your application. Not in every case, but it's correct for most applications. On the other hand, it may not be the cheapest solution. And of course, you can't use all the cloud services, which might help you even more. So the second strategy we'll talk about is using platform as a service, also known as lift and extend. One example for that service would be AWS Elastic Beanstalk, and that is a service for hosting your applications. In the easiest scenario, you can just upload your, let's say, Spring Boot application or whatever application you have, and all the rest is done by AWS. It runs, you don't have to care about any operating system, about no patches, whatever, except for your application itself, of course. That's a very easy way to get an application in the cloud. And in most cases, you won't need much changes to your application. So it's quite cheap in comparison to other strategies we will talk about later. So one disadvantage is that you don't have any control over over your operating system where that application runs on. But ask yourself, do you really need that? Do you want that? So in most cases you don't. So that can be a disadvantage, but can be an advantage too. So for that migration strategy, I have an example here, what we did in the recent past for an vehicle manufacturer, very big one in Bavaria. And these are actual stories from our Jira. So let's have a look in detail what we did here. First of all, you have to plan that. I can't stress that enough. Don't take your application and deploy it somewhere and hope for the best. That might work, but probably it won't be the best solution. So plan all that stuff. What we did here as a second step is we prepared for the changes. In that case, we implemented more tests, and we made sure that the application is deployable on your local machine so that we can more easily test that. And you might wonder why we didn't have tests in the first place. The easy answer here is that we didn't implement that service in the first place. So we only had we were paid for deploying that in the cloud and not for developing that. So that's why we had to write tests because the provider which did that before didn't have that many tests. So we only want to change code when we have tests for that. So that's why we decided to write massively tests here. Then afterwards, we refactor and update the application. That's a good opportunity to get rid of old code which you don't need and refactor all that old stuff you might have in your application. In that case, we migrated to Java 11, for example. So it's right now a really modern application. Then we adjusted the monitoring and checked if the logging is still valid, because in the cloud some details are different, especially when you're working for a big company. Then there are probably many systems for monitoring, for logging, and they have to work together. So that is probably a thing you have to keep in mind. And same for security. Another partner did a pen test, a penetration test, so that we can be sure that the application is at least secure enough You probably know that there is no 100% certainty that there is no security incident or security problem, but we tried our best, and the partner tried their best, and we fixed some minor issues here. Then, yes, of course, update documentation. Nobody likes that, but everybody has to do that. We did that really because it's closed here. So yes, we did update the documentation. Nothing is worse than wrong documentation. It's even worse than no documentation. So if you don't have documentation, write one. If you have documentation, update it. And one good tip, generally when you move to the cloud, try to automate as much as you can. In our case, we use Terraform for infrastructure as code here. So with the Terraform script, we are able to generate or to provide the infrastructure as many times as we want in different regions, in different availability zones, whatever. So we have a test environment, end-to-end production, and you name it. So that is a really good tip. Do that right from the beginning, and that will help you a lot. And same is for the deployment pipelines. We try to always use pipelines for automatic deployment, and that will help a lot when you try to use the cloud. Or it's the same for classical IT, of course, but we try always to use as much as automation as possible. Which was not in scope here was migration of data, and you may ask why, because we don't have any data. So it's completely stateless application. That's why that is or was the first application we migrated to the cloud. Not the very first application, but the first application from that big project we are working on. It's quite easy to migrate an application to the cloud when there is no data to migrate. And of course, afterwards deploy it in the cloud, which is quite easy when you have your pipelines in place. Then in an ideal world, it's only one click and it's deployed in that case, AWS EKS, which is Elastic Kubernetes Service. And with that setup, we are able to scale that application massively to whatever size we need. So the next strategy we will see here is, I call it rework. You can think of the using platform as a service, but with a little more work before you migrate. So the reason is that you can use a little bit more cloud power. And it gives you a really good opportunity to clean up your application. So like I said before, write tests, remove unused code, remove or replace some classes you don't need, and so on. That will lead, of course, to more implementation effort, but it will pay off by having a really modern application in, for example, AWS Elastic Beanstalk, or wherever you want to deploy that. So the next strategy will be the hybrid extension. That's very interesting alternative. You could extract some services or some functions from your application, from your maybe monolith, and deploy only these small functions, for example, in AWS Lambda, which is a service for function as a service for those who don't know what that is. And that helps you so that this function or these functions you extract from your monolith can scale massively. So for example, you have one monolith and there is one class or one module of that monolith which is called constantly and which is slowing down the whole application. So that would be a good candidate for extracting and deploying in the cloud. So you can do that with most applications, but you have to keep in mind that there will be more or a higher latency when these two systems, your old one and, for example, in that case, the Lambda services communicate, because there's public internet in between. There are several solutions which lower the latency and, of course, which handle the security for between these two applications or these services. But anyway, you have to keep in mind that the latency will be higher than as if both applications run in your local computing center. So the next strategy is the cloud native implementation. So what does that mean? Basically, throw away all your old application and implement it completely new. Of course, you can reuse some business logic classes or some other details, but basically that means implement it completely new with a cloud in mind. So that might lead to that to the goal that your application is not any application anymore, but for example, you can split that up in different Lambda functions, or you use Lambda functions and EKS, and the data can be distributed in Aurora serverless and whatever. You can really use everything the cloud provides. That, of course, will lead to high implementation efforts, obviously, but it can pay off. It depends, of course, if your application is suitable to do that, or or if you go better with just deploying that to an EC2 instance or whatever. So there is no golden rule here. You have to decide case by case. We have an example for that too. I blurred the application name here a bit, so that might reveal a little bit too much of details here. So the application here we moved to AWS existed in the old computing center, and we completely removed them and implemented that service completely from scratch, in that case with a Spring Boot basis. And all that stories you see here are, again, actual stories from one epic. You don't see every story here because that's only one part, but it gives you an idea. Again, first thing is plan. Then we prepared the project setup. In that case, we prepared the database and prepared the Spring Boot, the basis for the application. Nothing special here. Then again, you saw that before, we introduced Terraform. We are using Jenkins for the application pipeline and the deployment later on. Then there are a lot of features. We won't talk about them. It's of course dependent on the application. Again, the monitoring and logging. I told you before, there are some specialties in the cloud or differences, and later on we will update the documentation because we are right in the middle of that migration here. So we are working right now on the update of documentation, and we will that time have to migrate data, and afterwards and finally it will be deployed in the cloud. Again, we are using AWS EKS. So this is a real example, and we are about to finalize that in the next few weeks or so, but we're in a good way here. So we have two more strategies I want to talk about. They are technical like the others before. That one is software as a service. So one example could be Console CM as a service. That is our product, which is kind of a business process modeling tool and a ticket system, and it's very flexible tool. You can do more or less everything which is based on some processes in your company, and a little bit more, but yeah, you get the idea. So what we do here is that we might replace our own implementation completely by one system which is offered by a partner. And so we don't have anything to do about the deployment, about the development, and we don't care about operating system and all that stuff. We are users of that software. So that, of course, in most cases will cost you some license or usage costs. Maybe you will have teaching efforts if you change the application. Yeah, but it might again pay off because you don't have to implement all that stuff by yourself. And the last one, finally, business process as a service. So we are now at the, when you remember that, that triangle I showed before, at the very bottom. So we have a very high abstraction level here. One example would be to outsource your invoicing completely. That's not really a cloud migration subject here, but it's the most abstract level of outsource something. So you can think of outsource any process you don't want to do by yourself. And of course, you won't have any implementation costs here. There might be migration costs because data might be migrated, but yeah, no IT costs in the first place. So now I have a few tips for you. First of all, plan all that stuff. I mentioned that before. Try not to hurry into that cloud migration subject without any plan. It can work, but probably that won't be the best way. For planning, one thing you have to keep in mind is the costs, of course. Try to calculate the rough costs before you start. So it doesn't make any sense to migrate an application to the cloud and afterwards realizing that it costs double than before, then you probably did something wrong here. So one question I hear very often is, with which application should I start? So one suggestion from my side is start with the most easiest way or application, or start with the most painful application. So most easiest way, I think you get the idea what that might be. Most painful here means with which application do I gain most when I move that to the cloud? That might be an application which uses too much, I don't know, hard drive space, or it uses too much computing power, whatever that might be. Try to identify this application or that group of application and see if it's a good idea to migrate these first to the cloud, so that all that pain points will hopefully disappear. And the last tip from my side is use infrastructure as code. Like I said before, we are using Terraform, but you can use CloudFormation or whatever tool you like. Do that right from the beginning. It will pay off. So let's come to the roundup. First of all, we talked about crises. What can cause a crisis? Why do we need crisis-proof software at all? Then we talked about the cloud, how the cloud can help in that case. Then we saw a little bit or a few migration strategies, and I showed you some tips and tricks. And now I hope I could give you an overview about the migration strategies and how the cloud can help you in many ways. So it can possibly save you money. It provides flexibility, massive scalability, and it can hopefully prevent crises. So remember two things: plan first, and afterwards do it, and do it the right way. So that's it from my side. So I'm happy to hear your questions now.
Yeah, Michael here again. So everybody who wants to ask a question, please either type them out, or I think you should be able to unmute your microphones and just ask. Okay, I have a written one here, and that is somebody wants to know what the most challenging part of the migrations you just told us about was. So yeah, I guess from all of them.
Okay, the most challenging part of the migration, I guess the planning beforehand, and we of course tried to not forget anything about that migration. So that was one hard part, and we are getting better with every migration, of course. And one other thing I can remember was the deployment automation. Like I said before, we try to automate as much as possible, and yeah, it's possible to automate much, but it costs, of course, and some nerves, but it's worth the effort.
Okay, I have another one here. You told us, I think it was in example 6 or so, that you completely re-implemented one of those services from scratch.
Yeah.
The one with the cloud native, I guess. Was it around?
Mm-hmm.
Yeah, there. Or one earlier. Yeah. Yeah. And what was the reason for that?
The reason for that one was that we want to modernize that application anyway. So the old application was built with a high pressure. We didn't implement that, but now we are responsible for that application, and we suggested to remove it completely because the maintenance was really a bad thing. It was not really maintainable. So even if we did not migrate that to the cloud, we would have put enormous efforts into modernizing that application. So we decided to remove that completely and implement it from scratch. So that was the reason why we did that for this application, especially. But of course, you can think of many reasons why you should do that cloud native implementation. Let's take the example, you want to use Lambda or function as a service. So in most cases, there is the cloud native implementation will be the way to go here. If you want to use all that cloud power, which AWS or Google Cloud or Microsoft Azure support, then at least you have to implement some parts completely from scratch. Yeah, and one thing could be that your application doesn't scale for whatever reason. So you can think of implement it completely new so that you have in mind the scalability and that you can use the scalability in the cloud with, for example, AWS, EKS, Lambda, whatever you want. Any more questions?
Like I said, just use the chat function if you want to write something, or raise your hand and I'll unmute you.
And of course, you can ask questions in German, not a problem.
No, it looks like you covered the scenarios so thoroughly that nobody has a question.
Okay, I don't know if it's a good or bad sign. I hope it's a good sign.
There is one. Somebody wants to know whether data governance is a big issue in your projects.
It's always an issue, of course. In our case, it's not a big issue. We, of course, have to think about the security and all that stuff and where we store your data or our data. But it wasn't a deal breaker here. As long as we have in mind that the data is more or less secure, or as secure as we can guarantee that, then in that case, in that project, it wasn't a problem. But that might, of course, be a problem when your law or your customers forbid that you can move your data to the cloud. That might help, or it might help to restrict the, let's say, let's take the example of AWS, restrict the data to one region, for example, Frankfurt, and do not use any regions in, I don't know, US or Brazil or wherever. That might help. Yeah, but it depends, of course, on the customer's needs and laws and so on. So did that answer your question?
Thanks. Yeah, looks like you answered it.
Yeah.
Satisfactorily.
Anything else?
Nope. Nope, doesn't look like it.
Okay, then thank you very much all for your attention and your presence here. Then thank you again. And to Michael, of course.
Sure.
And bye-bye and stay healthy.
Yeah. And till the next webinar.
Next week, right?